Hello and welcome to the construction site of the largest mass timber building in Slovenia, the InnoRenew Center of Excellence Institute's building in the coastal town of Izola. I am Prelovšek Niemelä, architect and researcher at InnoRenew Center of Excellence. I am authorized designer architect of this building, and I will explain the concept of plant monitoring of the building to predict aging of wood in correlation to weather conditions, microclimatic circumstances, and design of details.
The Institute's building complex of size 8,200 square meters will consist of a hybrid of timber, concrete and steel structure. The upper part of the complex, first to third floors, will be completely made of mass timber, mainly cross-laminated timber.
If we look at the traditional architecture in the coastal towns of Slovenia and here in the old town of Izola, we can see that narrow streets were designed to create particular microclimatic conditions to increase quality of life. Narrow streets provide cool shadow during summer heat, and they keep towns protected from strong winter winds. We can find here small street gardens, a sign of nature inside the town. Two main materials of the buildings here are stone and wood. Stone is used for the construction of massive walls and pavements. It is durable, keeps houses cool in summer and endures wind and weather. Wood has been used as load-bearing material of floor slabs and roofs, inner stairs, and as material of windows, doors, window shades, pergolas. It is very flexible material for construction. It allows easy maintenance, and it is used there where people can touch it, smell it, observe it, and live in it.
The InnoRenew Center of Excellence building complex is designed in a similar way with these two traditional materials on facade and interior, like stone facades and pavements, wooden ventilated facades in form of vertical pergola elements, wooden lamellas as window shades, inner wooden slab construction and stairs, and with various separated volumes and architectural shapes like arcades, covered balconies, and small narrow atriums. The diversity of architecture makes it possible to assess a wide range of parameters that influence the long-term appearance and performance of different facades. Looking at the facade drawings of the building complex, we have identified particular spots for measuring following parameters: temperature, relative humidity, illumination, wind speed, and dust. Additional monitored parameters will include the hygrothermal attributes of several facade layers and of flat roof and balcony layers on mass timber roof structures. A prototype sensor for determining the aging dynamics of a building's exterior elements and its facade will be installed in various locations. The sensor allows detailed monitoring microclimate affecting materials and different positions on and in the building, including all exposure sites and different shading configurations. The collected data will be used to improve dose response models for the determination of appearance changes along the building's service life. The same data will be used to validate finite element simulation tools used for the building's design. The appearance of the building will be continuously monitored by high-resolution color and thermal vision cameras installed in selected spots around the building. Structural monitoring of the building will be performed with accelerometers at the roof level in the middle of the largest plate spans, with LVDTs at the corner and middle of selected CLT walls and at selected support points.
In comparison with other case studies of monitored buildings, we will not perform only structural monitoring, but also monitoring of appearance of the wooden elements on the facade and inside different facade layers. This will give better insight into the behavior of wood in correlation to different microclimatic conditions that we created with architectural design to simulate traditional architectural elements of the local space. In this way, we do not only perform a logical extension of the historical space, but also predict the future behavior of architecture.